Okay, so here's our goal today. We're almost kind of reversing what we worked on with students last time, which would be instead of having those two binomials and using algebra tiles to actually find our product and actually go through and do the multiplication, we're now going to have this trinomial, and we are going to say, okay, so what would be those two factors that actually would produce that as our final product? So what I would recommend is actually start with some prior knowledge for students. So they have already experienced multiplying binomials. So we could do something like this for our activating strategy and just tell students, tell me, what are my two factors? So when I'm looking at this as a reminder, we know that we have something being multiplied by something else. So we've got two binomials in this case that are going to give me this as my product. So I would give this to students and have them turn and talk with their partner, come up with what my factors are. All right, and for those of you that weren't able to join last week, when we're thinking about algebra tiles, there's a few things students would know. One is that when they look at this tile right here, this is our x tile. So we would think of this as x squared. So we have x squared as positive and x squared as a negative. Same thing, we have this unit as our x. So this is positive x, and then red represents our negative x. And then our constant. So we have our negative constant, and then we also have our positive version. So I would ask students to look at this and decide, well, what are my factors really? Well, what should they be able to see? Okay, well, we have x squared. So students should be noticing that we really have x being multiplied by x. And we could model that if we wanted to, actually using a tile. So we could have them prove this if we wanted to. So, okay, so we've got that part. We also see we have 1, 2, 3, 4, 5, 6 positive units. So I could take and actually have those 6 positive units and have them represent it. Personally, I would have them actually physically do it so they don't get confused about the fact that they're seeing 6 x's. But remember, that was really x times that positive 1 unit when we went through and found the constants. So we've got 6 right there. And then the difference here is, I have a negative. So we know in that case, we are actually looking at a red. So I know I have actually a negative 1 unit, but I can prove that by saying positive x times a negative 1 gave me the negative. And then the positives times the negative equal a negative. All right, so I would use this kind of as that entry point and let students dig through. Make them explain to you, well, wait, how did we know that this was negative? Oh, because it was a positive times a negative. How did we know that this one was negative? And so forth. Have them defend the mathematics, but using their prior knowledge. You could do the same thing. You could maybe give some students this one. And then for others, the activating strategy, they could be looking at the second factor and thinking through, okay, what does this one give me? So I'm still seeing it's the x, and then I still have my minus 4. Same thing here, I've got my x, and then my minus 3, excuse me. So this is just to kind of remind them that we were doing multiplication before and finding a product. Okay, so at this point, let's actually start the fun stuff. So we have this trinomial, x squared plus 7x plus 10. And I would ask students, can we represent that using our tiles? Well, what do I know? I know that means I have 1 positive x squared. I also know that means I have 7 positive x's. So let me get 7 for us. 1, 2, 3, 4, 5, 6, 7. And I have 10 positive units. So I'm going to go ahead and add 10 positive units. All right. So as I'm doing this, our goal is we want to know what the factors are. So what gives us this as our final product, knowing that I have x squared plus 7x plus 10. So I'm going to ask students to try to build kind of the reverse. So what did we know? Well, we know that it actually gave us some form of a rectangle. So we're going to take these tiles and try to use the tiles to be able to do this as a representation. So what I'm doing right now is good old-fashioned guess and check. So what do I think it might look like? So I'm just trying to fill in pieces to see what could happen. All right. So I'm taking my lovely little pieces, and here we go, trying to build and make that rectangle to help me find my factors. All right, now, for this, the beauty in this is letting students experience it. Let them kind of wrestle with it. So if we look at this, did I make a rectangle? No, so it didn't work. So if I'm wrestling through this and trying to find my answer, I might have to go through and look at different combinations. 2, 4, 6, 8. Y'all, I only have 9 tiles. Let me add a 10th. So sorry. Let's count again. But still, do we agree? Did I have what I needed? No. All right, so if I keep going through and rearranging my tiles, can I get to have a rectangle? All right, so what did I find? When I rearranged and shifted, it did work. All right, so what did this mean then if I'm looking at it? I'm still seeing that I had my x squared, I had my 7 x's, and I had my positive 10. But how did I find those? Well, if we think about it, I had an x, and then up here I had 1, 2, 3, 4, 5 positive units. And I know it's positive because I'm seeing my representation that I had just positive for my x term and just a positive for my constant. All right. Now, if I'm looking at the side, what do I have? Well, I still have that x, so I can see that as the length. But now in this case, I have 2 positive units. All right. So what that tells me is if I was to check my answer, I can see that I have x squared. I have x times 5, 5x here. I have 2 times x, 2x here to total my 7. And I have my plus 10. So in that process, I've found my 2 factors. I have x plus 5, and I also have x plus 2. Now, the point of this is to get students to see it. So I know I kind of made that just a one time, it didn't work, and then it worked. Let students figure out how to create the rectangle, because what that's doing is they're creating the product using the different tiles, using the different terms within our expression. And that's helping them to find what was really being multiplied together to get that product. All right, so I started with kind of an easier one to get us going. Let me show you another one that's a little similar so that we have some base to kind of get going as we're beginning. So consider this one with me. All right, so we've got x squared minus 5x plus 4. So if you have your algebra tiles, I want you to start to set up what do we know? We know we have x squared, all right, and you've got negative 5x, so I have 5 negative x tiles. And again, as you have questions, please feel free to ask or use that chat feature. Okay, what else do we have? We have 4 positive 1 tiles, or the constant of positive 4. All right, my goal is I want to find what needs to be multiplied by, what multiplied by another binomial will give me this as my final product. So let's build that rectangle. Okay, so on your own, you're hopefully over there trying to build and think through. Now, for this, it's all about kind of letting the students discover, but I'm asking them to start thinking about how are they finding their answer. So I'm kind of guessing here. All right, well, if I did this, I'm able to build my rectangle, but I have a bit of a problem because I still have an extra x. So I'm going to keep trying to reform this to see if there's a way that I can find the factors for this expression. I noticed maybe I could move this, so it's still not working. So I'm reshaping until, oh gosh, wait a minute. Here we go. I have my rectangle. So I'm shaping it and thinking as I keep doing it, what did I have to use to find that solution? All right, well, in this particular example, I see that my factor for the top then became just a positive x. And now I'm noticing that these are red, and red to me represents negative tiles. So I see that I actually have 4 negative 1 units. So my constant of negative 4 is my first factor. All right, so if I were to write this out, I see I have x minus 4. Okay, I need to find my second factor. So in this case, I still have that positive x tile because this represented positive x squared. So I know I have the x, but now again I see I have that negative. So I'm going to go ahead and represent that with a negative 1 unit. So this really then is x minus 1. Now, the one thing that I'm going to point out with students on this one is why were these yellow? And we're doing this to kind of re-trigger some of our prior knowledge. So when we're thinking about integers from the year before, I'm going to have them defend to me why was this yellow. And they're going to show me that a negative times a negative is equal to a positive. So that's why my 1 unit was still positive, even though I had 5 negative x values for my second term. Okay? All right, thumbs up or a chat. Did you follow me on the first couple? Because these are a little bit different because we're almost having to think through how do I build it versus the other one where we kind of set it up and multiply. How are we doing? Okay.
Start.
Thumbs up.
Hit start video.
All right, I'm going with silence means we're ready for a different one. Okay, all right, so let's move on. So if I were to give us this one instead. All right, so I want to look at x squared plus 2x minus 8. And the first two, I'm going to be honest, we're doing on purpose for students. We want to set it up where they can kind of see what they're trying to do. They're trying to build that rectangle to represent their product so that they can find what those two factors would be. So let's look at this one. What do I need in this given trinomial? Well, I know I have an x squared again, so I'm going to go ahead and get my tile for my x squared. And in this case, I see I have a positive 2x, so I'm going to go ahead and represent that. And I also see that for my constant, I have 8 negative. So I have negative 8, excuse me. All right, so I'm building. And now I'm not going to answer this one for students. I'm going to tell them to get started and start thinking about what can we do. 1, 2, 3, 4, 5, 6, 7, 8. So I have a problem with talking to y'all and counting. All right, so we're here. So we have our negative 8. Okay, so if you have tiles with you, I want you to try to build that rectangle for me using these. All right, so I'm brainstorming ideas. Now I notice this one's different because we're using negative. So even if I was to put an x on both of these sides, I'm noticing that that would give me a positive here because a positive times a positive is not a negative. Okay, so I'm gonna have to put him up here. All right, so this is creating a problem for me because what I'm seeing is I've got some empty spaces, right? All right, so thinking through what can I ever do? Let's see. Well, I still want to make a rectangle, so I'm going to use my shapes to try to help me. All right, even if I put them here, I have an empty spot, so that's not going to help me. But it's possible I could go in this direction to make my square, or my rectangle, excuse me. I could even maybe shift these 4 all the way up here, but I don't know if that's really going to help me. Okay, so we're going to be stumped in the classroom. We have a little bit of a dilemma because did I make my rectangle? No, but I know that I have a solution for this. I can find 2 factors that when I multiply them together will give me x squared plus 2x minus 8. So in this case, this is what I see right now that represents the problem. There's only one way that we can find the possible solutions here, all right? And there's a couple things that we can think about. Is there a way I can introduce something into our representation that doesn't change the value? Well, yes, there is. If I was thinking about this specific problem, I could introduce 0 because I didn't actually change the value of my particular expression when I added a positive x along with a negative x, because what this represents is a 0 pair. Same thing like if I was to look at my 1 units. I could technically introduce these 2 into my expression, and it wouldn't change the overall value because, again, -1 plus +1 is a 0 pair. All right, but in this case, does it help me? The ones? No. Could this possibly help me into building my actual rectangle? Well, yeah, because I could put an x here, and I could put an x here. And I'm still following that positive and negative gives me a negative. All right, did I get the shape I need yet? Well, no. Could I introduce another 0 pair, still not changing the value, and it work? Well, yeah, because I could put 1 here, and I could put the negative here. Do I now have my rectangle? Okay, so this part is a little bit more, we're really having to trigger and remind them about those 0 pairs. But remember when we did it, when we were multiplying the other direction, we were already talking about how these were 0 pairs. So that's why it's so key that we start with multiplying, so that when we get into this, it's not going to be as shocking to them. But if we look at this, what do we see? We have an x squared. We have positive 4x. We have negative 2x. And we have negative 8. Did I technically change what it looks like? I guess. But did I change the actual value of this problem? No, because when I put these together, what do they equal? Positive 2x. So by adding the 0 pairs, it's helping me to find my factors. So if I looked at this one then, I really have an x, and then I'm seeing 1, 2, 3, 4 positive 1 units. So my first factor for x squared plus 2x minus 8 is actually considered x plus 4. Okay, I'm going to do it again on the second factor. So I see my positive x. But now in this case, I'm seeing that I actually have those negative values when I'm looking at it. So I'm going to have to represent that with my negative 1 unit. And what do I know I have then here? Positive x. And then a minus 2. Let me slide this over so we can see it. And a minus 2. Okay, so in this case then, I found my 2 factors, but it was just a little bit more because we had to look at adding those 0 pairs. Okay, so this one's kind of a little bit more wild. So do you guys want to see one more where I first show you how to use algebra tiles to find the missing pieces before we shift to representational? Thumbs up, I'm seeing a heads up, yes. And one thing I want to let you know is our goal is to get out of this. We're not going to live in here too long, and I'm going to show you how to shift, but we're trying to give meaning to the math. So we're trying to really explain why what we're doing works, and I'll connect it all in just a minute. So hang in with me and trust me. For students, they're just building this rectangle and they're thinking through of how do I scaffold to get there. All right, so one more of this example with the algebra tiles. So I'm seeing x squared minus 4x minus 12, and I am going through and thinking, how can I use algebra tiles to represent it? Okay, so first things first, we're getting the pieces. We have x squared, and in this particular example, we happen to have minus 4x. So we're going to go ahead and add those minus 4x. And I promise you, once you get this and it clicks, like the first one, the one I just did feels a little odd. Once you get it and it clicks, you're like, oh gosh, this is awesome. All right, so I've got the minus 4x, and then I get to have 12 negative 1 units shared into this. So we're at 6, negative 8, negative 10, negative 12. All right, oh boy, here we go. Let's get building. Okay, so again, I know I have my x squared. And again, I'm noticing actually that I have all these little 1 units, and I have quite a few of them. Now, I'm thinking through what does it mean to equal a negative when I'm using multiplication. So it's not going to be a negative times a negative, because that's a positive. And it's not going to be a positive times a positive. So I have to have where one of my x tiles is positive and one of them is negative. And I also have to have a way that I can put these all together to where that makes a rectangle. So right now, if I was to represent this, I could maybe put these up here. And I'm still just trying to think through how to build that rectangle to represent this as the product. All right, is it working out for me right now? No. And the biggest thing is I'm noticing even here it's not working out for me. So I'm wondering how I could at least make my 1 units into a rectangle. So that would be one possibility. Another could be I could shift these down here to make a rectangle, but this would throw it off. So I'm going to stick with perhaps this, this particular shape. But again, I've got to come up with how can I use 0 pairs to kind of fill in those missing pieces. So if I looked at this and I want to introduce it as a 0 pair, because I did not change the value of my final answer, I just added in 0, all right? When I do that, I'm getting closer to having my final answer, all right? But I'm still missing 1 more. So let's see, how can I shift that? Again, I could introduce a 0 pair. So I have 1 here, and I have 1 here. Do I now have my rectangle? Yes, all right, so by golly, we're ready to go ahead and find our factors. So one thing I know is that I have a positive x, and then up here, I'm seeing that I have negative for my tiles, and I have 1, 2, 3, 4, 5, 6 of those. So I have a negative 6 unit. And the reason that I have them build it is so that they're not thinking in terms of x. Remember, this is a unit that got multiplied to give us that negative x. All right, so there's one piece. Boom, I've got that. All right, I've also over here got to build that I've got a positive x, but now I see two positive x tiles. So if I'm going to represent this one, then I'm going to have to use the positive 1 units. Okay, so if I check my work, x times x, x squared, x times negative 6 gives me negative 6x, 2 times x gives me positive 2x, and then positive 2 times negative 6 gives me negative 12. So I've found my factors that way then. So I really have x minus 6, and then x plus 2. And there's my answer. Okay, so our goal is to shift students. We don't want to live in here the whole time where the only way they can find the factors is building rectangles. Is it very efficient? No. But what it does do is it gives us meaning to what we're working on. So I'm going to actually have us go back and think about how we represented these using area models and actually just drawing the representation. And we'll help that to make some of the connections. So I'm going to pick one of our more basic ones that we started with first, and then I'll go to this one that was a little more complex. So give me a second. I'm going to slide back to, I think we did this as the second example. Okay, so if we looked at this one and we were to go through and think of how we built it, all right, when we were making the shape, there were a few things that were easy to us. So I'm going to go ahead and represent this now using that area model representation to think about what we did. Okay, what was the easiest part of this? I knew my x squared, right? So I knew that right here, this was x squared. And I could show that that was the factor of x times x. Now after that, when we were trying to build the rest of the shape, usually if we were thinking this through, okay, we were trying to put our x's in place, but ultimately where did we need to look next to think through how to build this rectangle? We had to think about this piece right here, right? So we were really looking at these 1 units and trying to figure out how can I make that shape into a rectangle. So in this particular example, if I was thinking that through, I saw that I had a 4 by 1, right? Like if we were to visualize this, we had a 4 by 1. But another option could have been 2 by 2, right? As we're thinking through our different pieces. So I'm visualizing how to get the different shapes that work for a rectangle. Now in this case, I also know because it's positive, it's not just an option that it's got to be the positive values. We could have done a negative times a negative, which is actually what we did for this one. Or we could have done -2 times -2. Those were all of the combinations in our mind that we were really working when we're thinking this through. All right, so what we knew though was that we had to get -5 for our x value. So even though we knew this was 4, we had to think through how can we get it where these tiles, the x ones, add up to equal that -5. So if we were looking through at our different combinations, so we had 4 tiles, wait, these are positives, that's not going to give it to me. But when we looked at this, we had 4 negative x and then 1 negative. So this combination here when we were thinking it through. So really, I could view it as the -4, and I probably would have flipped this if I was thinking it through. The -4 that we had and the -1. Well, what's a negative times a negative? A positive. But when I go through and do the rest of my area model, I'm still getting, oh sorry y'all, I'm still getting the actual pieces that I need to add up to equal -5. Right? So I'm using the shapes to manipulate until I find what works. Now most of us, isn't that what we're typically doing? We're trying to teach them that first, okay, the easy one was our x's, and then our eyes go where? We look at the end, the 4, and we're thinking, what gives us combinations that will give us +4? And then our next piece in our mind is saying, but what adds up to give us -5? So the difference here really is we're helping students see that adding up portion, the why behind it, versus we're just doing it, okay? Let's try another one. I know it's kind of, you're going, Debbie, this is not clicking fully, so let me show you another one. Okay, so if we go back to this example, in the end, we found it to be x minus 6 and then x plus 2, right? So those were our 2 factors that we found. But if I was to think through the process we used as we built that rectangle using the area model, once again, when I thought of all my pieces, what was the easiest? The go-to? X squared, right? So we have x times x times x gives us that x squared. Okay, then for this one, remember, we were trying to manipulate, but we were trying to figure out how we could make it so it still becomes this negative 12. And really our eyes then went to this 1 unit. So I know I need to build negative 12 somehow. So in our mind, we were thinking through, how can I reshape these negative tiles to get there? So one of the combinations we see right here, it was really looking at that negative 2 times negative 6, excuse me, the positive 2 times negative 6 to give us the negative 12. That was one of the combinations. Well, what was another combination? We could have done, technically, a 3 by 4, right? That would have been a possibility. But it didn't help us to add up our x tiles. But in my mind, I could have been thinking through as that as a possibility. So I could be saying, all right, so I could do a 3 by 4, and I could have it where it might be negative for the 4, it might be negative for the 3. So really this manipulation is the same process as what we teach our students normally when we're going through and thinking about what gives us that negative 12. But the meaning falls to, we had to be able to build it so that these two different values, the products that we got for our x's when they were multiplied, are going to add up to give us negative 4. Well, which combination did that? It was the combination where we had the negative 6, and it was a combination where we had the positive 2. So that we were able to see negative 6x plus this 2x still gives me 4 negative tiles. And we can see those were our 2 0 pairs left with our 4 negative. So it's a little bit more complex when we're thinking it through, but it really does help your student that is struggling to make the connection of the rule. When normally we say, okay, now look here, think what multiplies, now try to add it together. This is a tactile way of letting students literally see what we're doing when we're manipulating those numbers. Okay? All right, now, this concept is really what you can continue to do over and over again for different scenarios, to where we're really getting the students to use the area model as they're thinking it through. So for any of the examples, they could choose to use just the original and no longer need the tiles. So then they'd say, okay, I know my x squared. And then they'd say, okay, I know I've got to get this negative 8. And now I'm thinking through those combinations that are helping me, where when I add them together and get rid of my 0 pairs, I know what I have for my final answer. So we're really looking at how do we make those connections as we went through. Okay? All right, questions, because I kind of talked a lot right there, and I know it's a little bit of a process. Once you get going, now I went faster for the Zoom purpose because I know we're limited to 30 minutes. The power in the classroom is we let them make this discovery. So look, I would be asking them like, well, how did you figure out how to build this rectangle? What did you do first? So they would talk through the easy part. And then I say, well, how did you figure out where you needed to put this? What were you having to manipulate? They're going to own that this was really them thinking through different combinations to build that rectangle. And then how did they add together afterwards? So we're going to push students to articulate it as they do the discovery with the questions. All right? Questions for me kind of on the process of the reversing using the algebra tiles. You're all quiet today. I'm not hearing any voices. If anyone's trying to talk but you can't hear me, feel free to text it also if I'm not responding. Okay, so down the road, you could do the same thing even with like some of our scenarios that get a little more complex where we might have a coefficient in front of the x. The only difference is we're going to now build those 2x squared so that we would literally see that it was 2 x's when we're building it. So it's the same concept, it's just a little bit more tricky, but you use the exact same learning that you can represent any of the pieces, okay? All right, so my goal has been we're doing 4:30 to 5 each day. So are there any questions left for the good of the group? So Jeff, your group saying it's good. I'm just curious. So I know we have Sweetwater here, and I know we have Jones, we have Creekland. Who else is with us today? Cruz? I don't know. So I'm going to be honest. Pinckneyville, yay! I'm going to be honest with y'all. I'm slightly obsessed with next, well, it's going to be after Thanksgiving, so you're all going to have a fabulous Thursday. I know you're going to be like, oh my gosh, if only we could be doing algebra tiles with Debbie on Thursday. But the week after Thanksgiving, when we learn about completing the square, it's going to rock your world if you've never seen it before. It's so cool. All right, so we've got Jordan, we've got Radloff, we've got Bay Creek, we've got Grace Snell, we've got Cruz. Oh my gosh, I love it. I love it. Sweetwater, Pinckneyville, Creekland.
North
Y'all are
Gwinnett.
so awesome. Jones. Okay, so summer hour.
North Gwinnett.
All right, so the big thing is as you're working through this, you're going to want to practice a few before you do it with students, and start with some of the ones that are kind of obvious for them. If you have students though that they get everything in a 2-second, really on the spot, give them some of the more complex ones from the start and let them wrestle with it. Meet students where they are and where they need to be pushed. North Gwinnett, yay, I love it, I love it. What I did do, and then I'm gonna honor our time so we can go, is I have added everything on the mock. So we have where these links were. The actual like icon that says Zoom, if you click it, it's a hyperlink, and I have added the resources. So, I mean, you all can make this, I know that. But if you even wanted to print this algebra tile mat, you could. And there's the questions that I pulled. I have ones there that you can steal and use with your students as they work through them. So you're welcome to take everything. I'm going to keep posting the videos up there too, so you can go back to it. Let me see if I can share it. Let's see. Do I have it logged in? That is the question. I'm trying to see if I can find how I can reshare. If you go actually to, and I'm having trouble getting it to let me see my normal screen again. Let's see if this works. Okay, so if we're on the mock and you actually go, can you all see the mock? I think, okay. If we actually go to it where it says just in time algebra instructional strategies, and welcome Trickham as well. If you actually click on that link, I have added all of the handouts and files so you can download them. So they're all on there for you once I can get it to kind of show. So this is the one for multiplying, and then we have some more for factoring. And then I will put this video up there as well so you can rewatch it as we work through and kind of think through how to do it. But the power in it is kind of you also having a chance to dig through and try it on your own first before we then use it with students. But let them discover it. Let them kind of dig through. Your art is going to be having those moments where you pull it back in, like, oh my gosh. So did anyone have trouble with this? What were some ideas? Oh, 0 pairs. And help to kind of just thread it back in with them while you're working. Okay? All right? So our next Zoom is going to be the Thursday after Thanksgiving, the end of the month. I can't remember the specific date. We're going to do Completing the Square. It's going to be awesome. I'm really excited to show you that because that's a great way of giving meaning to a very rule-based strategy. So students will see why we're doing what we're doing. So it's really cool. And I'm thinking after that, I'm probably going to send out a survey just to see is there any other strategy from first semester that you could use some support with in terms of an AKS. And we may do some just-in-times as we get ready for preparing for that final for our first semester. So here to support you all, but I want to honor your time, and I took 4 extra minutes. So thank you. Please have a great Thanksgiving break. I know y'all earned it. You have 1 day left. 1 day. All right, thank you. See you later. Have a great day. All right. And thank you, everybody, for attending. Love it.